All right, so we started this lesson last class, and we're going very slowly through it. But remember, working with quadratic formula. So sometimes we end up with a negative underneath the radical, which means we've created an imaginary number, because if you square two negatives or two positives, you're still going to get a positive. So if you have a negative under there, then like I said, we use the baby I to represent that, and we say it's an imaginary number. If we're solving a word problem and it comes out that way, it will be no solution. So we reduce all of the terms of the fraction. So there's technically three numbers outside that make outside of the quadratic or the radical that will make fractions, and you have to solve all three of those or reduce all three of those. You can't just reduce two of the three, so they all have to share. And then you can't cross over from radical to non-radical. That just separates. And then you're going to have two answers because there's the plus and the minus. So we worked through the first page of this last class, and we ended up finishing 1 and 2 from the back. And remember, you have to have your equation in standard form, ax squared plus bx plus c, and then your ABC is used. You have to determine those, and then we'll put it into quadratic formula. Opposite b plus or minus the radical b squared minus 4ac all over 2a. Work the radical first. It's just like gymnasts, grouping, and the radical is treated as a grouping. So the first one we're going to look at, number 3. What would be the standard form for number 3?
Negative x squared plus x plus 1.
Yes. Now, I know when we were factoring these, we needed the lead coefficient to always be positive, but you remember when we were graphing, it didn't matter. It doesn't matter here. But we need all the numbers together, making it equal 0 as such, and then when we go to use the quadratic formula, we're only going to have it x involved. There's no y involved in the quadratic formula. Do you remember why? Why is x so important?
You're trying to find
What is on the x when we're graphing?
axis of some vertex.
Not the vertex. It's always your solution. When you solve, that's where the solution is going to be, on the x-axis. So what we're looking for still is this. It's on the x-axis, the solution for x. You can take any equation thrown at you, any quadratic equation, even if it's one that you struggled with graphing or with factoring, and put it in here. This works for everything. All right. Do you want to work this by yourself, or do you want us to work it together?
Question.
Yes.
How do you know, like, once you get done working it, and you like the little answer, the little one, how do you do it again?
All right, let's do this one together, and then we'll see what happens with number 4. So what is A?
1.
-1. B is 1, and C is 1. All right, so remember, this is the equation, this is your template, if you will, that we're going to use. All right, so let me tell you what. I'll put this, let me see if it'll lean.
Is it opposite B or negative B?
Opposite. Can y'all see it? I hope. There. All right, so when we go to fill it in, opposite B, which will be what? -1. This is x equals plus or minus, and then the big old radical. And we're going to have b squared. So put it in parentheses. -4 And then it's times A, which is -1, and times C, which is +1. All over 2A. And what is 2A? -2. All right, to save space, I usually work my radical up above the radical itself. And I just leave it under the radical. What's 1 squared? 1. Then -4 times -1 gives us 4. And what's 4 times 1? 4. +4. 1 plus 4. And what's 1 plus 4? So what we have as the radical is radical 5. All right, so we go to the next line. So x equals -1, plus, or opposite 1, if you will, plus or minus radical 5 all over -2. And I'm going to erase this -2 from the top line and move it down so you don't think that it's part of the radical 5. So, what's in front of the radical? Plus or minus what number's there? Since we don't really have one there. A 1. And radical 5, it's a prime number, so there's no perfect square, making it up, or anything like that. So here is our final answer. And do you see how it's 2 answers? It's -1 plus radical 5 over -2, and -1 minus radical 5 all over -2. So let me ask you something. I am going to, well, as we're moving into more difficult or complicated math, you're going to be directed to never have a denom that's negative. You always want a positive denominator. How can we make, in this case, we have a negative denominator. How can we make that -2 a +2? Multiply the whole thing. So, technically, what would we have as our answer? X equals, if we multiply the whole thing by -1, what's -1 times -1? So +1 plus or minus, and we'll have -1 outside radical 5 all over 2.
So the radical is not touched.
Nope, the radical is not touched. Well, you have that 1 outside of it, and you make it a -1. But the inside, that 5 stays positive. All right, number 4. Other than setting it up, let's see what you do. So our standard form is going to be what? Bless you. 3x squared what? Plus 2x, bless you, minus 7. What's A? A is your 3. What's B? -2. And what is C? No, +2. And what is C? -7. Bless you. You okay?
Disgusting.
No, I'm not sick.
So A is 3. B is 2. It's +2. And C is -7. All right, you want to work it by yourself? Yes, you do.
Can you like do like
I got 12 times 7.
if all 3 of them like out the outside, the denominator, and the inside, can you find a common factor for all of them?
All 3.
That's what.
But not worry about the radical, but all 3. Yes. And you can simplify. So I'll tell you what I'll do. I'll quietly work it while you work it. And so you can check in and see. Does that work?
What number are we doing?
4. And we did our A, B, and C
I got you.
for 4.
It's not where I go. Well, can you somehow?
What's 12 12 times 7.
Can you simplify this?
84.
6
Where'd you get 6 from?
2 times 3.
2 times 3.
What should you have as your handy dandy friend in working this?
Calculator. It's 80.
Calculator.
Where'd you get the 2 from? In the front?
I get it.
Opposite B.
How do you get like the final final with it?
Yeah, I get it.
But can you simplify it?
Well, I'm waiting to see what y'all got. Wait, where did, like, this part, you're good with this?
Like I got it to this. Like,
To this
small
part?
answer.
Oops, I forgot to put the square.
How to get it to, I don't know how to get it to like x equals.
All right, so did you work the discriminant, which is your radical? Did you solve it first?
I got it all the way down.
What'd you get when you solved the radical?
88.
So we have radical
Oh, I was saying that's 96.
88.
Yeah, 2 times 2 is
No, it's 84 times 4.
I thought you were math is not math.
Oh, I thought you.
Then you said
Well, it's negative 12 times negative 7,
84 times 4.
Yeah, I just did.
and then plus 4.
Okay, but then you gotta then you gotta
I got-
simplify, right?
Why is there a 6 under it?
Why'd you get
2a,
Oh, 2.
Wait, we did it wrong.
2 times 3.
I got
So it'd be 4 minus 8.
All right, can you break 88 down?
Yes,
Into what?
into 8 and 11.
Yeah, but okay, you could do that.
22 and 4.
That's where I'd go. Why?
Because it's smaller.
No, not because it's smaller.
Even.
4 is a perfect square.
Oh, yeah.
So you could have done 8 and 11, but then you got to break 8 down further into 4 and 2, and then 2 times 11. I mean, you've got more work to do. So 88 is going to break down into 4 times 22. And the 4 comes out as a 2. The 4 comes out as a 2. 22. What makes up 22? 11 and 2 is 2. I mean, it's prime. 11 is prime. We can't break that down. So while 22 is not a prime number, it is not made up of anything perfect. So the 22 just remains the radical. Okay? So this gives us x equals negative 2 plus or minus 2. Oh, I'm going to run into that 6. Hold on. I'm going to move it over here. Plus or minus 22 all over 6. Are you good to that point? Abels, you look confuddled.
So is the 2 from the 4?
Yes.
Okay. There.
So then you have a 2 plus or minus 2 all over 6. What do they share?
2.
Wait, Gabe, what?
Whoa, where
I'm
did
just-
2 come from? Where did 2 come from?
Okay, I got it. Never mind.
4, 22, 4.
4 times 22, so the 4 comes out as a 2.
Got it.
And then your outside fractions all share the factor of 2. So we're going to remove all of that. Whoops. So your final answer, x equals negative 1 plus or minus 1. Okay, what did you break 22 down into? What, Mary Thomas?
Don't break it
You don't break it down. Awesome. Because it is inside, you don't. It's not part of the simplifying unless you can break it down itself. 22 all over 3.
Wait, I thought you don't break it down unless all of them can be broken down.
2, 2, and 6 all share a 2. Right? The inside radical you don't touch when you're breaking down the fractional
You
parts.
just have to have them like all inside, like, the inside you can't, like, say you couldn't, say you couldn't break it down, like, say you have a 2 and a 6, but the inside's like
Oh,
23.
let's say, yeah, it had been 83. And 8 plus 3 is 11. It's not going to break down any further.
So you-
Then it was 1 radical 83. Then we're done because the 2 and the negative 2 and the 6 share, but there's a 1 where that 2 is. Good. I'm glad you made. I can't talk either. I'm glad you made that statement. Yes.
So if they all break down, you take away the radical?
No. It's still there. Radical 22.
Like if the if the 22 is a different number and it broke down, like if it was a 40 or 49 or that's not enough.
Okay, if it were a perfect square, it would be removed. The radical would be gone.
Like if it was a perfect square of 49.
You would remove and have a 7.
Yeah. So you and then you would remove the radical and then
Yeah, you just left with a radical because it's not perfect underneath.
if it's a perfect square, you
Then it's gone. Yeah, we worked one like that on the front page. Where it worked. All right. So number 5.
It's 19.
So what is our standard form?
I finished.
Everything minus 5.
So we would have a -1, a 4, and a -5. Okay. So I'm assuming you're working this one by yourself because y'all all seem ahead of me, which I love.
If it's,
I think I got it.
if they're all, like, if you don't want the denominator to be negative, do you multiply -1 including the square root thing?
Only the number outside the radical. But let's talk about this. What did you get under the radical?
-2.
-4. Because you should have had 16 minus 20.
Whoa.
And that would have given you radical -4,
Oh, yeah.
which is the negative comes out as a baby I, the imaginary number. And the radical 4 part becomes a 2. So hold on. Let me put this. So we would have x equals -4 plus or minus 4 squared minus 4 times 1 times -5. That gives us 16 minus 20. Okay? So that's all over -2. So we would have x equals -4 plus or minus. We know when we have radical -4, the negative comes out as the imaginary number, which leaves us with a +4.
Wait, how'd you get -4 in the beginning?
I had 16 4 squared is 16. And then we had -4, times a -1, which is +4, times -5, which gives us -20.
No, I mean like outside the radical, like the very first number, -4.
Oh, opposite B. B is 4, so it becomes -4. Yes, ma'am.
The trash can
Hold on. Is that better? I should move. You said trash can. You're right. That's right. Sorry. Is that better? Sorry about that. Yeah. Just took up that space. All right. So that means we're left with -4 plus or minus. Radical 4 became a +2. We have a baby I out there all over -2. Then when you break that down, 4 and 2, and everything shares. What do they share?
2.
Okay. How could I make it? Okay, we'll go with that first. So we're going to remove a 2. That's -2 plus or minus 1, baby I, all over negative 1. So what can I do to make that denominator become positive?
How did 2 get in front of the I? Does that matter?
Yes, it does. You have negative 4 as the radical. And that baby I is letting you know that that's a negative radical, which is an imaginary number. So it gets to be closest to it so that we don't lose that it was a negative. Because let's say we had negative 6 and the 6 would stay under the radical, it wouldn't break down any further. So you would have a number outside, but that baby I has to stay next to the radical sign to keep it negative. Not in front of the 2, but behind the 2 in this case. So how do we fix this so that the 1 is a positive 1 in the denom?
How's the negative one?
So x equals 1. Hold on, let me erase. I was multiplying by 1. 2 plus or minus negative 1, baby I. That would be your final answer.
Solved it.
Do what?
I solved it.
Yay!
Wait, how do you do that?
Math.
And then they would be over 1, but that's like a whole number.
So you just multiply everything?
By negative 1.
Do you have to put that
Gotcha.
final -1 in
That's
parentheses?
stupid.
Well, you would have plus or minus just negative 1. So yeah, you could have it outside. So I want you to do number 6 by yourself. And I tell you what, I won't say a word, but I'll slowly work mine along the way while you're working. Does that work? I saw some weird looks on your faces when I said by yourself. All right, I will start mine. Oh, yeah. X minus 1 squared. What does that mean you get to do? Foil. And then distribute the 4. And then move your 6x over as a negative 6x. Move the positive 2 over as a negative 2. All righty. So hopefully you got 4x squared minus 14x plus 2 as your standard form. Now that would be a doozy if I handed that one to you and said factor it.
What do I have to factor it?
I mean, it would be not an easy one because you would have all kinds of stuff happening. So this is why quadratic formula helps you solve it. So yeah, we're using quadratic formula, but this is where I'm saying you could take that kind of equation and it would be difficult to work otherwise. Who knows what negative 14 squared is?
343.
No.
Took a shot.
That's right. What's the denom?
Fraction.
No, it's not. Oh, what is the denom for our problem?
Oh, I don't have the data, but in the standard form, why is the last number, the C2 if it's 4 and 2?
Because it's 4 minus 2. The 2 comes over as a negative. Who has the denom yet? 8. 4 times 2. So 14 squared, or negative 14 squared, is 196. Has anyone worked out radical? You should have gotten 164.
Isn't that perfect square?
Nope.
I did. I got 186.
Oh, no. I got 164.
196 minus 32. That's going to give us 164. Negative 4 times 4 is negative 16. Negative 16 times 2 is negative 32. Negative 4 times A times C. Who's broken down 164?
4 times
8.
41.
Say it one more time.
I did 4 times
4, because y'all, 64. Using your divisibility rules. 4 will go into 64.
That's 2.
I got a course.
Okay.
I don't have a space.
How'd you get -2 for your C?
I don't. I have a C. A positive 2.
I mean, how'd you get +2 for your C?
You had, when you foiled and then distributed the 4, you should have gotten 4x squared minus 8x plus 4. You didn't distribute the 4.
I did -4 instead of a +4.
Oh, yeah, it's a plus 4. And then 4 minus 2 would give you the 2. So 4 times 41. The 4 comes out as a 2. So x equals 14 plus or minus 2 radical 41 all over 4. Oops, sorry, all over 8. I went ahead and simplified. All over 8. So what do we notice? 2. The 14, the 2, and the 8 all share. And we can simplify the fractional part by 2. So final answer,
7 plus minus
plus or minus
1.
1. Radical
41.
41
4.
all over 4. And if we were to say, how do we solve that without having a radical, we would take our handy dandy and put that second button, hit the x squared, type in 41 and hit enter. And that would give you what, and then you would plug that in. Okay, any questions?